Hi guys. Till date, you are more focused into linear motion, but now we have got to get into rotational motion. Now that doesn't mean you have got to forget your linear motion formats, what are formulae and all those things that you had. No, you have got to keep in mind those formulae and then convert them analogically into rotational motions. Alright, okay. I would be going phase wise. Initial phase, then second phase would be a little more in depth, and third phase would be the final, where we would try and convert most of the formulae that we have learned in linear to rotational motion. It's quite interesting. You have got to know this because in entire portion of physics you would be requiring these basic formats. So I'm just trying to put all this into a very simplest format. Okay, let's see how it works with you. All right, happy viewing. Let's try and understand some basics of physics which we will be requiring in most of the places in this video. Okay, so we are talking about linear displacement and angular displacement. Alright, in case of linear displacement, suppose if the distance covered is s in time t seconds, then velocity is distance over time. We know that there are three systems. Three systems are CGS, MKS and FPS. Now what we use is SI. Alright, SI system uses basically MKS. SI system is basically MKS system. Alright, MKS, if you go to MKS, it is length, mass and time. Length is measured in meters, mass is measured in kg and time is measured in seconds. So that's the basic unit that we use for most of the calculation unless mentioned otherwise. Alright, okay. So length obviously would be in meter and time would be in second. So velocity would be distance over time. Linear displacement or linear distance upon time, that would be meters per second. Alright, now this you have studied in 10th and all. Alright, now we are mostly going to tackle rotational motions. Alright, so let's get into rotational motions. But it is always better to keep all those formulae what you have by hearted or what you have learned in physics in linear motion, because that we can easily convert it into rotational motion. You would see how. Alright, now see, so we saw here displacement, now here it is angular displacement. Alright, so we always travel anti-clockwise direction. Most of the time we saw unit circle also we went in anti-clockwise direction. Okay, so here also say we are going in anti-clockwise direction and we were initially here. Now we covered up this much distance. Now if you talk in terms of distance, this becomes a linear distance, but the angle covered is theta. So we are right now concerned more with angular displacement. Alright, so angular displacement is theta. Now that theta was covered in t seconds. So it is theta over time. Now theta is measured in radians. Alright, radians per second. So theta is radians per seconds. Alright, now it could be degree per second also. It depends upon how many degrees. So it is radians per second. We know the conversion factor of degree to radian, right? We had seen that it is 360 degree corresponds to how many? 3.14 radians, approximately 3.14. So you can convert degree to radians. Alright, so it is radians per second. Alright, now suppose if it has covered the full circle. Alright, so full circle means how many degrees? It is 2 pi, 360 degrees, 2 pi degrees, right? So 2 pi over, and the time required for covering full circle is capital T. That capital T is known as time period. Alright, so what did we say? We told that when small angle is covered, we call it as theta. When full circumference is covered, the angle covered is 2 pi radians. So it would be 2 pi radians upon time, and that time has got specific name which is called as time period. Time required to cover full circle is time period. Okay, whereas small angle and small time and small angle and time required to cover that small angle is depicted this way, theta by small t. Whereas if it is full circle, then we depict it as 2 pi over capital T. Capital T here is time period. I hope it's clear. Okay. Another significant aspect I want to bring to your notice is that see omega, it is a bit congested, but I have no other choice. Omega we can also write it as 2 pi into 1 over t. Alright, and 1 over t is frequency, which is depicted by letter small n. Alright, so we depict it also by f. Alright, 2 pi f. So I would be writing omega is equal to either 2 pi n, or instead of n you can also use 2 pi small f. Alright, so this is one thing which you have got to keep in mind always.